My name is Lindsay Allen, and I am a scientist with the USDA ARS Western Human Nutrition Research Center in Davis and part of the faculty at University of California, Davis. I have spent many years working on nutrient requirements, and most recently measuring the nutrients in human milk. And that is what I'm going to tell you about. So my focus is on infancy and lactation. So first, I want to be really clear that I totally support the science, the wisdom between human milk being the best food for infants. It has so many advantages for the infant in terms of immunity, the gut microbiome, all the factors and bioactives that increase growth, cognitive development of the infant, and in theory, it supplies all the nutrients that the infant gets. Well, the infant is totally breastfeeding. That's the only source of nutrients for the baby. So it's very, very important that they're there in the milk in the right amounts. It also has advantages for the mother in bonding for the infant and some other outcomes. So I wanted to just briefly mention how we develop recommended intakes for infants and lactating women. So for most nutrients, how much the infant needs is calculated from knowing how much is in the breast milk, the concentration in terms of, for example, milligrams per milliliter or per liter, multiplied by the amount of milk that we assume the infant gets. And for most purposes, we assume 760 milliliters a day. So the product of the two, concentration times volume, is assumed to be the adequate intake for the infant. It's not very accurate for many reasons that I will mention. And then the mother needs the amount in addition to her normal recommendations to match the amount that she's secreting in breast milk every day. The problem with this approach is that there are very few studies of the amount of nutrients in human milk. Some of the recommendations are based on 3 women, data from 3 women, for example. Another problem is that many micronutrients in milk, that's minerals and vitamins, and I have a list of them in red, are lower in human milk if the maternal diet is poor quality and low in those nutrients. Another reason that there are few data is that working with milk and analyzing it is not the same as plasma. There are so many nutrients, and we cannot measure them one by one. And then the mother's diet or supplements can affect the values in the milk. And finally, another problem is that, in effect, not every infant is getting 760 milliliters per day. Some mothers produce a lot of milk, some very little, and we don't know what that does to the amount of micronutrients that the babies get. A mother who produces large milk volumes every day might have more dilute milk than one who's having a lower volume. So all these are some of the concerns about the present approach. When we do cross-sectional studies, these are many studies that we've done as collaborators and our own studies. And these are B vitamins in human milk. Across the top, you can see B1, B2, B3, and then the bottom, B6, B12, and choline. And these are the values in different countries that we've measured. They're mostly not random samples. They're chosen often to be in poor populations. But the red line across the top is the concentration that we assume when the Institute of Medicine or EFSA in Europe makes the recommendations for how much is in milk. And you can see for many countries, the percent of the AI is very low. So here's riboflavin, for example, and you can see in Bangladesh is only 10% of what we assume the infant is getting when we make the infant recommendations. And so you can see that the dietary patterns of the mothers or something is affecting the concentrations in milk. So we need to know what are normal values. And so what we've been doing is to set reference values for what the infant should be assuming that the infant should be getting, and a range of values around that reference point. So this is what we've been doing in our lab. We have 7 different instruments, mostly mass spectrometry, in which we can measure all the B vitamins at once, or most of them, and vitamin D, and do metabolomic measures. We do vitamin B12 a different way, immunology. ICP mass spec is for all the minerals. There's about 15 of those. Thiamine is a different method, vitamins A and E by high pressure liquid chromatography. So in less than 2 milliliters of milk, we can measure all these nutrients. So this is why we've been able to collect a lot of new information. So this study that we've been doing is called the MILQ study, MILQ, Mothers, Infants, Lactation Quality. And the goal is to establish reference values for how much is in each nutrient is in milk across the first 9 months of lactation. So we have selected well-nourished but not supplemented mothers, 4 countries, 1,000 dyads, mothers and infants, and a lot of other data. So the idea is this, like the WHO growth standards, but upside down, that we will be able to get the percentiles for each nutrient across lactation. So these are our collaborators in Denmark, in the Gambia, a well-nourished population in Bangladesh, and in Rio de Janeiro. And this is our measurement schedule, some of the measurements that we're making, and we do them in windows across the first 8.5 months. So we have data for almost every day. So milk is collected, milk volume is collected, measured every time as well. So just a couple of examples. Here is lactose, which is very stable across sites. There's hardly any variability in lactose. These 4 colors are the different sites that we measure it in. And these are Z-scores for differences among sites, among each other, and they're very similar, as we would expect. If you look at vitamin D, though, here are data in which the green site, I can't give you the name of the studies until we publish them later this year. This has very low concentrations of vitamin D in milk, and also the mothers have low values and the babies have low values. And finally, another example, this is zinc, and you could see, as we knew, a large fall during lactation. And the values in our study will give you a concentration for every day postpartum, whereas what happens right now is they just take the average of the first 6 months. And so what happens is that the value that is found in, used in the...
Yes, we hear you.
Right. Yeah, okay. So what we find is the Institute of Medicine uses 2.5 milligrams of liter because they're averaging this whole 6 months, but we find 1.1 is the median value across that time. So in other words, for this nutrient, the present requirements are far higher than they are in reality. Another thing that we want to do is to build models like this. So over here, we'll be able to understand what really affects the nutrient concentrations and total amount in milk. And so we have many, many other measures, including the dietary intake of each nutrient, maternal status. We have biomarkers in her plasma and a lot of other factors as well, such as parity, body mass index, milk volume. And so we'll be able to figure out what really affects the concentrations in milk. So in summary, the recommended intakes we have now for infants and mothers in lactation are based on sparse data, and much of it is very wrong. We can measure multiple micronutrients at once, many nutrients, actually macro and micro. Many of them have rarely been studied, and we can compare the values across populations. At least 12 micronutrients can be very low in milk if the mother is not eating properly. So the global situation is almost unknown, and so are the effects of levels of intake in the infants and the effects on the microbiome in the infant and so on. Some of the milk values used now to set infant and mother requirements are wrong. We're finding most of them are actually overestimated, not under. We will actually have milk volume measurements each time we measure the micronutrient concentrations, so we will know the actual intakes from milk. And we were studying with other people the most effective ways to supplement the mother or fortify foods for the mother. Do we have to start in pregnancy? Can we start in lactation? What dose is effective? Because actually only very small percent of supplements appear in milk. And so this needs much better understanding than we have. And so finally, developing these RVs for milk nutrients is the next step to understanding the situation. So this is our team meeting in Denmark last year from 4 countries, very strong collaborators, actually 7 countries all involved. And these are some of the people we've worked with in our research in different countries, with the ones in red working in the milk study. So with that, I think that's my main message. We need to know more about nutrients in milk.